All right, this is Solutions Podcast number 1. This is an introduction to solutions. So in this video, what you see is one of my favorite demonstrations, and I'll make sure to do this one for you guys in class. Basically what it is copper that is put into 17 molar nitric acid, which gives off a reddish brown gas called nitrogen dioxide. And then when you add water, copper 2 nitrate solution forms as a result. And that's that beautiful blue solution that you see. And it is a homogeneous mixture, and it is in one phase. So I want to talk to you a little bit about what makes up the solution. And most of you are already very much aware that the solvent, for example, water, and the solute, for example, salt, make up the solution. You've already learned that. I'm just making sure that I'm giving you all of the background information you need in this introductory podcast. These homogeneous mixtures, with the naked eye, you really can't tell the difference. So if you consider, say, sugar water, where sugar is dissolved in water, sugar being the solute, water being the solvent, even air with the oxygen gas and nitrogen gas and other inert gases that are part of this, the air we breathe, carbonated water has a gas in a liquid phase. Alloys. Alloys also have, those are two solids, two metals that combine, but you really can't tell the difference when you're looking at them because they are homogeneous throughout. So I want to get a term defined for you, and that is miscibility. Miscibility is the ability of a liquid solute to dissolve in a liquid solvent to form a homogeneous solution. So an example of this would be alcohol and water. When you mix those two, they are miscible, which means they are homogeneous throughout. This, however, is an example of something that is immiscible. These are not miscible. The vegetable oil and the water are not considered miscible. Other examples of miscible, gasoline is miscible. Gasoline has benzene and toluene and some different compounds in it, but it looks homogeneous throughout. Unlike this oil and water, which clearly forms two layers to separate out and is therefore called immiscible. Okay, so a suspension is a heterogeneous mixture in which some of the particles settle out. So upon standing, these larger particles will eventually settle to the bottom. So an example would be water and sand suspension. That's probably one of the most common examples of a suspension, but over time it will settle out. So there's a big difference between the size of the particle, the sand, and then the solvent, the water, so much so that it is very clear that they separate into two layers, okay? A colloid, on the other hand, is a heterogeneous mixture, especially on the microscopic scale. Now, on the macroscopic scale, it may appear to be the same throughout. Milk is a colloid, okay? And it doesn't just have to be liquid states of matter. Fog is a colloid. Smoke is a colloid. So you've got liquid and air or gas, and then a gas and a gas. So different states of matter can form colloids. The key is that we have one particle that is evenly dispersed throughout another one. And there is a size difference, but that size difference is intermediate when compared to a homogeneous solution and, say, a suspension, okay? So here's something that's really cool, and we can certainly do this in class as well. You can take a solution and a colloid, and you can distinguish between them by shining a light through them or even shining a laser through them. And you can see that the solution on the left is not showing any of the light. It's not bending or diffracting any of that light, whereas the colloid on the right is, and it'll do the same with the laser. And driving in the fog, you notice this with the headlights of a vehicle as well. So this is known as the Tyndall effect, okay? The Tyndall effect is that scattering of light that you saw in that last image. And it's happening among those colloidal particles, okay? So the Tyndall effect is something you associate with as a property of a colloid. Okay, so how about separating the substances within a mixture? We can separate them a number of ways. We can use chemical separation. And in the unknown metals molar mass stoichiometry video, that example 2, I actually went over an example. And in lab, you have used chemical separation by adding 2 chemicals together to force out a precipitate and then collect or filter that precipitate and weigh it and use stoichiometry to figure out what the different constituents are there. So that's one method you could use. And then we have physical separations. Physical separations can be classified as either mechanical or non-mechanical. Mechanical would be gravity, some sort of contact force, some sort of motion between those components, whereas a non-mechanical separation would be the heat, electricity, magnetism, simple dissolving, capillary action, and chromatography is even an example. So here are a couple examples of mechanical separation. Decanting is something we'll do often in lab. Filtering, we've already filtered in several of our labs, but again, that involves a mechanical separation, the motion of those components. Another example, using a centrifuge, all right? We use centrifuges in class as well. And so that that force that's exerted, which is a fictitious force called the centrifugal force, but that outward force, which is not a true force, I want to make sure you understand that. It's really simply inertia and a resistance to motion. However, keyword motion. We have motion of those components that can separate out the substances in the solution. So chromatography, I want to take a moment and really talk about that. I'm guessing most of you have done some chromatography in biology, maybe some chlorophyll A work. We have some chromatography that we'll probably get to in this course. If you're in the biotech pathway, you've definitely done some really cool chromatography. No pun intended there. But this is a mechanical method, and it's basically separating out the substances in a solution by using a mobile phase, such as a liquid or gas, and a stationary phase, okay, such as a silica gel or even a paper stationary phase. All right, and so you're able to separate substances out using chromatography. And when we get to talking about bonding, we're going to revisit this idea on a whole new level. Okay, so in our introductory podcast for solutions, I am setting the foundation for you to begin to understand differences between terms like solvation and dissolution. You're going to carry out a number of labs looking at how the solute involves a specific solvent and what factors can impact solubility. And so in closing, I have good news for you, class. You do not have any problem set associated with this podcast. So I will see you guys in class.